So, hello everybody. Thank you for coming to the conference and to this session, first real session after the keynote. The camera is already recording, so now it's a good time if you want to say hi to your mother, to step in front of it and wave a bit. After that introduction, we'll start doing some more serious things. So the title of the session is Introducing R and Azure Machine Learning, Azure ML. I am Dejan Sarka. I am working in IT sector for nearly 30 years. And actually my first job was data mining. Basically, it was even not called data mining. I dealt a lot with statistics in university, institute, and faculty for sociology. I am dealing mostly with SQL Server now, still with business intelligence, and still with these advanced tasks like data mining and now machine learning. You probably noticed that I'm not a native speaker. I'm from Slovenia, so I just finished my 13th book. So if you don't understand me, send me an email. Seems like people understand me better when I'm writing. So if you have any problems with accent, please interrupt me, ask me. Of course, I will repeat the same thing with the same accent, but at least we can get somewhere. And if it's still not understandable, just please send me an email. So what I'm going to talk about is R and Azure Machine Learning. And you know that nowadays, this is very fashionable. Everybody wants to do some kind of data science, programming, statistics, data mining, machine learning, of course, big data. These are now buzzwords nowadays. So where does R fit in? Actually, in Microsoft Suite, we have business intelligence developing from SQL 7. SQL 7 in '98 brought first time analysis services. Data mining first try was included in SQL 2000. And then it became quite mature in 2005. Did a little bit development 2008, and then it was more or less there, unchanged till 2014, when Microsoft shifted a lot to the cloud. So one of the problems why Microsoft didn't become so big player in this field is that data mining is mostly developed in universities, and people mostly use tools that are around from 50s. So statistical packages like SAS and SPSS started to develop in 50s already. And since these are the packages that are widely spread, it's not so easy to come into this area and say, now I have this great product, everybody starts using this. However, Microsoft did make an important change. Suddenly with SQL Server, data mining was affordable for masses. You know, packages like SAS and SPSS are extremely expensive if you don't have some kind of academic license. It can be extremely expensive for business. Now with data mining included in SQL Server Suite in analysis services, if you've got SQL Server, you're done with all of the licensing. Also, Microsoft went even step further and released data mining add-ins for Office, especially for Excel, which enabled data mining even for broader audience. Still, as I said, Microsoft was somehow lonely in this field. So the amount of algorithms is limited. Even Microsoft cannot afford enough developers to develop all possible algorithms that are around, known in the scientific world. Oh, and by the way, as I said, statistics, data mining, it mostly comes from universities, from academic world, so it has some specific rules that are not so common in business. So in data mining, all algorithms are public. Basically, you can get information about any algorithm that was ever developed, all of the mathematics behind, and what you do, you create your own product. So this is how data mining works. And also Microsoft developed some own algorithms like sequence clustering and published complete mathematics behind, so any other company can take it and include this algorithm in their own product. Anyway, since, as I said, the amount of algorithms that Microsoft supported was still kind of low compared to competitors' products, although all of the most important algorithms are there, so it's not like you would be lacking something for a real life project. Microsoft decided to make a breakthrough by supporting R. In Azure ML, R is supported. So what is R? So R is statistical programming language, open source language or package, based on S language that was developed in 70s and early 80s in Bell Labs. So it's not just the algorithms, also the complete package, also the complete product is free. And because it is free, it is extremely popular, again, in academic environment, in universities. So it has become the most popular product in last 10 years in universities and even managed to overwhelm and overcome SPSS and SAS. So suddenly by supporting R, Microsoft got access to hundreds of different algorithms or hundreds of versions of the same algorithm, which might be good, but also might be bad. Now, in the second part of this talk, I'm going to introduce Azure ML. Let me start now by introducing R, and then we'll talk about pros and cons for supporting this in a business-oriented product. Basically, you will see we have this gap between academic and business world, which might be problematic sometimes. So, R is available free of charge. It is distributed under terms of the Free Software Foundation's GNU General Public License. And there is core team that is developing R, and homepage is at www.r-project.org, so you can download R from there. R engine and R interactive command prompt. So we have a lot of statistical functions already built in. We have a lot of graphic functionality. And we have hundreds, or not hundreds, thousands of packages that expand functionality that you get out of the box. And of course, there are some drawbacks. So it is kind of programming language, so you have to get used to it. And it's based on, as I said, university, academic world, especially statisticians contributed a lot to R. So one of the things that might be kind of very hard for you if you are not proficient with mathematical or statistical fundamentals is terminology. So it's, R is not using any kind of business-oriented terminology. A lot of statistical terms, and even in help, help is organized more academically than business-oriented. So typically, when you start researching something, you immediately open help at Google and search for the terms. What does this term mean, and what does that term mean? The fact that it is open is also kind of drawback. We have many different competing, overlapping procedures, algorithms for the same task. So it's literally impossible to check all of different algorithms for clustering. For example, you've got in R to select the best one for your needs. Also, these packages are developed by different people. And there is no strong central organization that would enforce consistency. So even the language is not completely consistent. Later you will see just for assigning values to vectors, we have 4 different assignment operators. So it might be a bit confusing. And not all of these operators, even assignment operators, not all of them are supported by all of the packages. They try to enforce some kind of consistency, but as I said, this is open world, so you cannot really expect this kind of business level consistency you are used from Transact SQL or from Microsoft languages in general. So you can install it very simply from rproject.org. User account control is not being triggered. And R packages extend the language. So you just use a single R command, install.package, and then you specify the package name. And the package is automatically downloaded from some download or mirror R project download or some mirror site. So it is stored in compressed format, downloaded, unzipped automatically, and installed. Okay. Did I say a lie or what was it? I should take more care what I'm talking. Anyway, so as I said, with a single command, you are downloading a compressed file, unzipping it, and installing it in your local computer or your local server. You can immediately see that this might be a huge drawback. I mean, try to come to a bank and say, we are going to analyze your data in R, and I need all things open so I can download whatever with a single command. This simply doesn't work with business policies in place. So typically in business you use R more like for personal data overview, right? Or for some testing, and you are very careful before introducing this in production. Now, default invoking R is an interactive mode. Of course, you have also batch mode, but default is interactive. And you've got R console, which is kind of graphical interface. Basically, it's a command prompt. And then you write expression by expression, which is evaluated, and the result is returned. Fortunately, we have better than this. Besides R, there is also RStudio. So some people are developing RStudio, which is interactive development environment, similar to Visual Studio. And again, it's free and open source. So it's very recommendable that you download it from rstudio.com and install it if you want to use R. Now also, this installation doesn't trigger user account control, and you got regular updates for both R and RStudio. Usually it's around half a year time frame when you get next version. Now let's go to the R language basics, so you will see what we can do with it. By the end of this section, you will get some ideas how can you use and what can you do with R. So this is a functional language. So instead of typing commands, you call functions to achieve results. Even to quit R, you call a function Q. Okay? So functional languages are less prone on bugs. You know, functional languages are based on expressions that are Boolean expressions, logical expressions, evaluate on true or false. So if everything is all right inside the expression, it's hard to produce a bug. But also, this means they are limited, because not everything can be expressed through a predicate logic. So you can always get help about anything with help function. You can check the licensing information with the license function. You can check contributors to a package or to R itself with contributors function. And if you want to quote these contributions in some of your white papers or books, you can use the citation function to get this basic information. If you want to get some options about R and R Studio, which are default, or change them, you have options function, and you can even use source files, invoke them with source function, and save the results from the interactive console with the sync function. Please note that R is case sensitive, so if you copy this and write these functions by yourself, make sure that they are all small caps. So R is case sensitive. Comments start with a hash mark, and you can put them in line or in a separate line, whatever you wish. Comments are separated by semicolon or new line. So it's similar like transact SQL, which has semicolon, but it's not needed for all of commands. SQL Server can parse the text, and if it's keyword, can understand that this is a new command. Commands can be grouped together into more complex compound expressions by braces. And whatever you create, variables, entities, vectors, matrices, data tables, data frames, these are objects. And objects that you have in memory, please note in this free edition, we are limited with memory. There is also payable edition, which can spill the data out of memory. But it's not such a big issue anymore with modern computers. And also I will talk a little bit more later that you will see that you don't need huge data sets for data mining. So this is not really an obstacle anymore. But anyway, these current objects in memory, this is called workspace. And you can use objects function to list the current objects in workspace and remove objects that you don't need anymore, so you spare some memory. And at the end of our session, you can save this for the next session. But again, in this free edition, this workspace is completely loaded in the next session in memory. So objects are saved in the R data file, and all of your commands are saved in the R history file. And of course, you can create script files in advance with default extension R. Now, let me go and show you a bit of our first demo. How does it look like? So, I already installed it. So, this is our command prompt. This is the latest version, 3.13. This is like 14 days old. This is our command prompt, our console. Okay, and I'm not going to spend a lot of time here. I'm just using Q to quit. And I don't want to say workspace image. I will use R Studio, which is slightly more advanced environment, kind of resembles Visual Studio. So basically part of this R Studio is also R console. But it's even better than this because you can load a script and then move through script without this line after line approach. Okay? So I will just open a recent file, R basics R. Okay? So you see this is a comment, and these are these basic functions. So contributors to R, and here is this R information in a new window. So these are people which are the core R team. Help about options, remember options function, so you can get help and you can read help interactively while you are working in R Studio. That's very nice. I don't have any object yet in memory, but here are the textual results, so it's actually empty. Didn't create any object yet. Now, let me go to these basic expressions, and then I will switch to slides. So we have basic arithmetic expressions, right? 1 plus 1 equals 2. And you see, whatever I write in script is actually transferred to the R console, and I got results in R console. Of course, later we will see also graphical results. This is my objects. This is my workspace. So objects function lists everything that's here. When I will create some variable or some data frame, it will appear here. And of course, we have this operator precedence like you would expect in any kind of programming language. So like multiplication was executed before summarization. So 3 multiplied by 4 is 12, plus 2 is 14. And we have exponential, so 3 on third exponent is 27. And of course, we have some functions like square root and constant like pi. Okay. Now let me go to basic assignments. So this is first and probably most widely used assignment operator. So this lower sign and minus or dash. So this is assignment from left. I'm assigning a value from the expression from the right to the variable or to the object from the left. So now I'm creating variable x that will store value 2. I will introduce data types in a minute. And variable y that will store value 3, and variable z that will store value 4. And as you can see, I can execute multiple lines in RStudio. And these multiple lines were executed line by line in console prompt. Okay. And then I can make calculation based on my variables. Of course, the result is still the same. Remember, R is case sensitive, so also names are case sensitive. So of course, I got an error. There is no variable capital X. You can use periods in names, so you can kind of. This is not like kind of official namespaces like in .NET or schemas like in SQL Server. It's just for your help, so you can use this in the same way as you use namespaces in .NET or schemas and relational databases, okay, to make groups of variables. So I can create a variable called this.year and assign value 2015, and then I can check the content. And you see now in global environment as well, all of these variables appeared. So these variables are already occupying my memory. Now, second way of assigning, and again this is left assignment, is equals operator. And if you want to be on the safe side, this assignment operator is typically supported by every single package. So if you want to be on the safe side, you will use the upper one. Though we have also equals, which is kind of more natural, more common in other languages. So this is completely the same thing, assigning 2 to x, 3 to y, and 4 to z, and then calculating x plus y multiplied by z. And remember, equals is assignment operator. If I want to check for equality, Boolean equality test, I have to use 2 equals operators, like in C#, x equals 2, and this now returns true because x is 2. Okay. Just from these basics, you can already see that it's not really consistent language in a way like you are used by business-oriented languages like C# or Transact SQL. Okay. So variables are basically numeric, Boolean, and string. And type is determined automatically, which is good and bad thing. This automatic typing is usually good when you start dealing with something, so it shortens your time to create your first application or your first procedure, but in longer terms, it's better to have strong typing. I prefer to have strict control over data types. And we created them with this basic assignment operator, lower and dash characters, And of course, name is case sensitive and can include a period. Now, R is mathematically oriented, so we have a lot of mathematical structures supported in R. And we don't have seriously supported tables from relational model, from SQL Server. We have something that is close to a table, but not table in relational term. So it's more, as I said, mathematically oriented. So first collection, let's say that we have are vectors. These are collections, ordered collections of numbers. You create them with C function, which simply concatenates elements to vectors. So creates vectors from numbers or from variables. You can repeat some elements with rep function, or you can generate sequences with seq function. So you can use most of mathematical functions and operators on vectors, and full vector algebra is supported. So if you know vector algebra from mathematics, you can, all of these basic mathematical operators are overloaded in R, so they support this vector algebra and work correctly as you would expect from mathematics. And you use brackets, square brackets, to select elements. You can select elements by position. You can exclude some elements. There are many ways how you can use it, and we will use it a lot in further demos. Now, vector has a single dimension. Matrices have more than one dimension. Matrices are generally two-dimensional. Arrays are multi-dimensional. Then we have a special kind of vectors. Lists are general form of vectors, where various elements do not need to be of the same data type. Now they can be character strings, for example. And then from lists we can create factors, which is actually selecting distinct strings. And these strings are then called levels, distinct values. Now data frames are matrix-like structure, which is the closest thing that gets to the table from core R. They are still ordered, so we know what is third row, what is fifth column. We can refer to them with ordinal positions. But we have two-dimensional structure where columns have names. Right? We don't assign a key, but we can find a specific value through position, like specific row. And you can also write your own functions, so temporary functions, which can be stored in your workspace for the next R session. Now, how do you use SQL Server data or any kind of relational data in R? So first you need to get a SQL Server ODBC driver. R is missing. We are talking about R, and R is missing there. Okay, so we need ODBC driver, and then you create a system data source name. And of course this comes with SQL Server, or you can download SQL native client. And then in R you have to install R ODBC package. So now we come for the first time to this installation part. And then you load the package or activate the package, load the package in memory, and then create the connection object and read the data in the data frame. That's it. So let me show you how these things work. So first we have some kind of collections. Right? We have vectors. So we create vectors, for example, by repeating values. So this is a vector of 10 ones. Or we can create a sequence from 3 to 7. Right? Or of course, this is a shortcut for sequence. Go away. This is a shortcut to sequence. And we can also define that we want only every third integer in the sequence, not all of the integers. So we have sequence 5, 8, 11, 14, 17. Now, how do we store these vectors in variables? Again, with assignment operator. And this is one way. We already know the left assignment operator, and we already met the equals operator, which is left assignment, another way how to write left assignment operator. But we have also right assignment operator, so we are assigning this value to the variable on the right of the expression. And we even have assign function. So the name of the variable y will store this vector created with C function and with values 1, 9, 9, 9. So I have 4 different ways how to assign values, and I'm not really sure if there is not another way in some package I never touched so far, okay? What I know so far is 4 different ways of assigning values. And then operators, basic operators, mathematical operators are overloaded. So we are supporting vector arithmetics. So like summarizing 2 vectors means summarizing values on the same position. So first position, vector x is 2. And vector y is 1, so the result is 3, and so on. And multiplying a vector by a constant means multiplying every value in the vector by a constant. So we are multiplying vector 2, 0, 0, 4 by 4, so we get 8, 0, 0, 16. And now this is stored in, this was just an ad hoc calculation, so it's not stored in the x. So if I make square root of x, I'm making square root of this original values 2, 0, 0, 4. So I get square root of 2 and 0 and 0 and 2. Now let's go back and assign this value 2, 0, 0, 4 to vector x. Now this is how you can refer to values by position. So in position 1 I had value 2. And by using negative position means excluding this position from the vector. So the result is vector without the first element of the original vector. And I can assign a value to a single value inside the vector, to a single vector element, or to all elements but one. Okay. Now let's create another vector. We can compare vector to a constant value, which means we are comparing every element to this constant value. Now let me change something, change the 4th element to 1 and make this comparison again, and the result is different. So you see now the last comparison returned true. And we can even have logical expressions to filter elements. So I'm assigning value 2 to all elements of vector y which are lower, smaller than 8. So smaller than 8 was 1, it was 1991, so now it's 2992. We have this simple vector x. Now please note I'm writing 2 comments in a single line now, also to show you the comment separator. So I'm assigning value to vector x, and then I'm showing x in the same line, and comments are separated by semicolon. Okay, and I'm creating a 2-dimensional array or a matrix from this vector. So this is done by array function, which accepts a vector and a dimensionality vector. This is another vector with fixed name dim. And I'm using the C function to create this dimensionality, 2 rows and 3 columns. Factor. Please note that this is now a list, a vector of character strings. So I have A, B, C, D, A, B, C. So A, B, C is repeating twice. So if I create a factor in R out of this, I get these levels, only distinct values. So A, B, C, D are distinct values in this original vector. These are these so-called levels. List can be, list is a generalized vector. So I have list that consists of 4 variables: name, wife, number of children, and children ages is actually a subvector. So I have a person that has 2 children with ages 3 and 6. In list, I need double brackets to refer to an element. With double brackets, you are referring to the full element. And this syntax is here because you can refer. Remember that I can have a subvector in a list, so I can refer also to an element of the subvector with a single bracket. So it's the 4th element of the list, the 2nd element of the subvector ages of the children, and the 2nd age is 6. Now I will create a data frame, okay, which is the closest thing you can get, the closest to a table you can get from the core R. So I'm using read.table function, and please note it's not a table in SQL Server sense, so it is ordered, order matters. And I'm reading from a comma-separated values file. So this is from Adventure World ZW demo database product categories, which I actually exported them using export wizard, which created SSIS package for me. And I have header, so first line are column names, and I define separator. So this is my data frame. Now, I can see data frame here. So you see, it appears like a table. And this is basically what you are analyzing in R, data frames. However, I don't have a key. I don't have operations like join, filtering, except filtering by position. Filtering rows by position. Of course, projecting works because I have column names. So like select part of transact SQL would work, projecting works, but not filtering by the key because I don't have a key. Now, you see, this is how you install a package. It's already installed, but I can repeat it just to show you how the process goes. So it goes to some URL, downloads, unpacked, unzips the package, and installs the binaries. Now please note, in any serious R session, you are installing a lot of packages. So, you know, this is something, as I said, you cannot go to a bank and say, yeah, we are doing this. Just a single line, and we are getting code from somewhere and installing on your server. This doesn't work. Anyway, it's still good for in a controlled environment. Now with library command, I actually loaded this in memory, so now it's available to me. I created the DSN name in advance, and of course you can use also Windows security, but for the sake of simplicity, I used the state-of-the-art security features. You know, so I'm connecting with a user I created in SQL Server with very complex password. Now I read data as a data frame. So I create a data frame with as function, as data frame, and I'm getting this data frame from SQL query, which uses connection, and this is basically transact SQL. So this is what I'm sending to SQL server. And I don't want to change strings to factors. You know, by default, it would automatically create factors. Remember what factors are? Lists of distinct values from strings. So I don't want to do this. Okay, this is done, so I can check my data frame. And now I'm more or less prepared for analysis. So this is my data frame. Of course, it's not very nice to check it here, right, in this kind of environment. But I can check it from here. this data frame, and say it in a tabular format. And by the way, when I clicked here, in this window on my data frame, I actually created this command, view data frame. I can also use this command from my console, from my script, and you see, get it here as well. So, next step, go back to slides. There is one additional package called data.table that can create something that is even more similar to SQL Server table than data frame. As I said, out of the box, from core R, data frame is the closest thing to the table. Now with data table package, you can create data table from a data frame. So we have column names, we can define keys, which allow by default duplicates. And this is still not SQL Server table. Keys define sort order, so it's still ordered. Okay? You can still refer to a row by position, not just by the key. And it's needed because this is not constraint. This is not primary key or unique constraint. It's just a way how to refer to this data in your filtering expressions. So like for where clause. And then you can aggregate data and group data. So you have like aggregate functions and group by expression inside R, filtering based on keys or other expressions. And you can even create join between two data tables. However, this is still very limited. If you need to manipulate the data, you should do it before R. You know, manipulate with set-oriented manipulations, you should do it in SQL Server. So, joins, the only join that is supported has multiple names. It's called fast order join, also called last observation carried forward join, also called rolling join. How many of you know how many different join types SQL Server supports? How many algorithms does it have internally? Nested loops. SQL Server has nested loops, hash, merge join. So merge join is very limited, can be very fast, but it's also very limited. So merge join means you have sorted tables from left and right, sorted by the joining key. So you take key from the left, go to the right, and because it's sorted, you simply scan until you find a value greater than this value. And then you take this value from the right and go back to the left and scan the left side until you find greater value. And then back to right and so on. So basically it's very fast in a single threaded environment. It's a very fast join, but it's limited to equi-join. You can join only based on equals operator. Both inputs must be sorted. Okay? This is basically what R supports, the only kind of join. So if you have outer joins, or if you cannot afford sorted values, you can use hash joins. You should do the joining in an RDBMS part and then export the results to R. Now what you can do with this, of course, we want to analyze the data. So basically we have a lot of functions for generating graphs. So we can generate bars, we can generate histograms, we can generate plots like scatter plots. And some of these functions you can use in a very simple way, but then you can make it more and more complex. So for example, this plot will use a data table. So this is predicate, like in where clause. And I'm referring to the key. So this is not possible in a data frame. I'm not referring to the position, but to a logical expression, all rows with customer key lower than 11,010. And then this is the projection. So this is the column I'm going to use, number cars out. But please note the syntax is still more matrix-like. So rows, columns. So you see, in brackets, I define rows and columns. And I can define them through expressions. So this part is like select and where part of transact SQL statement. And these are types. Now, as I said, these packages, these functions are created by different developers. So they have different ideas what is intuitive for users, for you. So plot with dot plots, this developer had the idea that it's very intuitive to use low caps O to denote dots. So low caps O means scatter plot. Is it intuitive? It was for somebody that developed this. Okay? There are even better things you will see later, like if you want to calculate count, you have to specify statistics equals bin, and so on. Depends on the package. You see, the consistency is a bit problematic in R. You have hundreds, if not thousands of packages. You have all possible statistical functions, all possible data mining algorithms. Everything is for free, but there is a price for this. So I also want to have lines besides dots, right? And I also want to have legend and title. And I define also fonts and so on. So for all of these expressions for the plot function, you need to check the help. There is, of course, help and examples. There is no simple way. And as I said, it's not really consistent. So you take some other package. This plot is in the core R, so you don't need to install any package. But later we will see the most popular graphical library, ggplot, ggplot2. It uses different conventions for denoting what kind of plot do you want. So there is no other way than checking the help. And help is not written business user friendly. It's written statisticians friendly. Okay. And then you can get summary of the data set. Please note different ways how you calculate basic statistics. You have summary function, you have sapply function, you have aggregate function. So again, a lot of different ways to achieve nearly the same or completely the same thing. And they are not, as I said, they are not always consistent. So here, sapply, I'm using on my my data table, right? And I'm calculating mean and median. And here I'm defining first list of columns, and then which will be used, and then projection in my data table. So kind of different syntax again. I'm kind of defining projection twice. As I said, there is no other way than to check specific library help to see what kind of syntax it supports. It's not that bad. Most of developers try to achieve some kind of consistency. Okay? And this basically, how do you refer to elements of a data frame? This is prescribed. So it must be always first rows. So you see this is comma, means on the left there is nothing, means all rows, one column. So this is defined. So you will always refer to a subset of a data frame by rows, columns. But other things, as I said, like defining scatter plot dots with small caps O, this depends on a developer. ggplot2 is a very useful graphical library. So you have to install the package, and then you can build all kind of charts. So for example, here is a chart that has on x-axis education, on y bike buyer, and it's filled by region and also split by region. So different regions have different bars in different column. I will also mention this and then go to the end with this R demos and switch to Azure ML. So we have a lot of algorithms in R, and if you are interested in data mining, and so I have tomorrow 2 sessions, first two morning sessions about data mining algorithms. I will explain all of the most popular data mining algorithms, how they work in analysis services, in Excel, in R. Now this is just for a taste. So for example, decision trees. So decision trees is the most popular data mining algorithm because it's very simple to understand. You have a target variable and you use some input variables. Target variable is a discrete one, has either binary or a couple of values. And then you try to explain those values with input variables. So for example, in my data set, I will have a target variable bike buyer, whether this person has purchased bike in the past or not, and use other variables to understand what drives people to decide to buy a bike. Now when I have this data, I can make predictions on new data sets. So I have like demographic data, I can make a prediction whether this person is a potential bike buyer or not. So, for example, you can install a package. Again, why is it called party? I don't know. Somebody thought it was convenient name for a library or for package that includes decision trees. Okay. Maybe they got ideas on some parties. This is how this naming convention in R. And then you train the model, and then you can show the model. So let me go and finish this R demos. So I already installed, so I don't need to reinstall package data table. Now this is help about data table, so you should always check help for every package to see the naming conventions inside the package. Now I'm creating a data table, and now when data table is created from my data frame, I can set a key. And now I can get tables info, and I can view my data table. It looks here completely the same as data frame, just I can do many more things now with data table than I could do with data frame. So for example, I can get a specific row by key, customer with key 11003. Or I can use some aggregate function, which is accidentally called sum. It's not always in all packages that sum is called sum. In core package or in core R, this is accidentally called sum. Okay. And this is kind of group by. So I'm grouping bike buyer by number of cars sold. And I can do a projection. You see all rows. This is consistent with data frame. All rows and subset of columns. Customer key and, oh, and by the way, F5 is not run. You don't notice this because you don't see me what I'm typing. But I pressed F5 so many times during this session. It's Control and Enter in RStudio. I pressed F5 so many times. So I have two projections, customer key and commute distance, and customer key and bike buyer. Please note they are ordered, so I can join them. And this is the syntax. I'm joining the second to the first one. So now I have joined with all columns. So this is kind of natural join. Let's go and show basic graphics. So I'm now doing everything on my data table. All of statistics and graphics works on data frame as well. And if you want to be on the safe side, you should use data frames. Data tables only for manipulation, set-oriented manipulation of data, and then convert back to data frames. Data frame is a native R object. So all kind of packages support data frame, but not all packages support data tables. So you might get into troubles if you are strictly using data tables for analysis. So convert data frame to data table, do the set-based manipulation, convert back to data frame, and use data frame for analysis. Histogram, and wow, you see I got graph here, I can zoom it, and I got histogram of number of cars owned, and I can also export it. Remember, sync is the function to export textual results. Here I can save this as image, copy to clipboard. And I can add a title, main title, number of cars owned. And I can add axis labels. You see, by default, axis label is just the expression I used from data table. Now I have different axis label. And I can even define color. So I can play with it and get a lot of different presentations. R supports a lot of colors. So with demo colors, you can see colors supported and their names here in the result. And there are many pages of this. That's why I have to hit return multiple times. So these are all colors supported by R. And how do we refer them by names? Okay, a lot of playing. Plot, couple of points, number of cars owned. And this is default, type equals O, means dots, and no, default is dots, and type O means add line through these dots. And I can make this more complex. I will define plot colors vector, blue and red, and then plot number of cars owned, and use lines and total children as well. And add a legend, so I get a little bit more complex graph of number of cars owned and total children with two different colors with a legend and so on. Basic statistics, create a summary, means create summary of descriptive statistics of all variables. So for, you see, for strings, I get only the count. For numerics, I get minimal, maximal value, first and third quartile, mean and median and mean values. So basic statistics for all the complete data set. And then I can have specific statistics with sapply function. So mean for number of cars owned and total children, or median. Right? Average or mean with group by. So this is like group by in Transact SQL. And this is again group by, just grouping by gender and education. Okay? Just to show you different syntax again. So it's the same command as here, okay, different variables used, but still I'm aggregating with group by. So here is the group by list after the tilde. So this is kind of shortcut for the previous syntax. Okay? And then also, yes. Let's see what I got in the results. So what is this? This is count. So again, somebody had the idea that function length is an intuitive name for count, aggregate function. Maybe I get this, you know, some of these naming are kind of logical. If you would draw a bar, this would be length of a bar, right? If you draw a horizontal bar. How do you get these names? Through help. That's it. And this is one of big drawbacks of R. You know, we have a lot of different conventions. And then you can make cross tabulation, and I will not go into all of details, but you see, code can immediately become quite complex. So I'm doing a cross tabulation, contingency table with chi-square test. This is basic test for correlation of two discrete variables. Okay, like Pearson correlation coefficient is for two continuous variables, right? However, again, you can install different package where this cross tabulation is already there with cross table function, so you get very, very nice output contingency table, and you can also calculate all kind of statistics and so on. Right? Like chi-square test. Pearson is a British statistician, also called the father of modern statistics, but he was not a nice person. You know how statistics started? Pearson wanted to find mathematical proof that white male are supreme to other races and women and so on. This is why he defined all of these statistics. He was genius, but okay. Started from a wrong assumption or whatever. Okay. Again, another package, right, installed. So we have a lot of packages that are competing. So I get different statistics. You see again this number of values, number of nulls, number of not applicable, mean, max, range, sum, median. And then I can also make this for subsets and so on. So we have a lot of different ways to achieve the same thing. Now I already installed ggplot2. Let me show you a couple of plots. So I'm showing a region count. You see, count of a region in these groups. And inside region, I'm splitting region based on education. And with not so complex slide, I can get this. Now, of course, these are stacked bars. If I want to have all of stacked bars of the same height, I use different command position equals fill. So I'm filling to the top. Again, is this intuitive position equals fill to get stacked bars of equal height? I don't know. But this is specific to ggplot. And position dodge, I get these clusters of bars for each region. Sorry. Clusters of bars for each region. I can get trellis chart, so this is chart of small charts. So for example, I'm checking occupation in two charts based on marital status. Or even more complex chart, education and bike buyer, which is by default getting, bike buyer has options 0 and 1. So I'm calculating sum of bike buyer. So I'm summarizing ones. So I have more bike buyers with bachelor's degree in Europe than with partial high school in North America. Okay? Syntax, whatever. I wanted to get this sum of bike buyers, so syntax is geom bar stat equals identity. So again, for the concrete syntax, please check the package you are using. And data mining, an example of decision trees. So, yeah, and you see that this is very, very, again, specific, very particular naming convention. So the package name is party, and it loaded also dependent packages, which are zoo, sandwich. So apparently this developer was in some kind of party in a zoo and developed this. No, it's just a warning loading. Okay. Why is it here? Because it's needed and I didn't specify. I think it's something like this. And then it's loaded out, then it's my command that all of dependencies should have to be loaded. Okay, nearly, nearly, okay. But it was loaded automatically, that's why it was warning. Now let me train the model. So I'm defining decision tree, bike buyer is dependent, and remember again this syntax with tilde. These are independent variables, and now I can show the results. And this is my decision tree, so what leads to buying a bike. So if we have number of cars lower or equal to 1 and region Pacific, and what is this number of cars equals 0, then we have 388 cases here with nearly 1 in bike buyer. So 90% of probability that people in this class are buying a bike. Also, these plots are defined by different developers. So let me show you another library, another decision tree with another library. And let me plot this one. So I got different picture. So also this interpretation, you should check help how you should interpret these results. It's close, but it's not the same. Okay, let me now switch to Azure ML. A couple of words. So of course, yes, first a little bit of marketing, as everything goes to machine learning. Formal definition, okay, computer program should learn from experience and improve some performance for some tasks that it's doing. So basically machine learning refers to computers, applications, while data mining refers to people. However, many times we use them as synonyms. Please note that there is one big difference. So data mining is always working on samples. So you have two possibilities. Either you have small data set and complex algorithm, or huge data set and simple algorithm. So machine learning also uses simple algorithms on huge data sets. Remember last football championship? Probably you want to forget it, but I want to give you an example. You know that Microsoft did very good predictions with machine learning about the games. This was an example using big data, really huge amounts of data with simply calculating means. So they used data from all kinds of online betting websites. So they got data, they got contract with many, many different sites, bwin and other betting companies. And they were simply averaging those results. This is not data mining. And can you do complex algorithms on huge amounts of data? Basically, yes, if you have enough time. That's it. You know, use decision trees on a couple of millions of rows, and the training will take you a week. That's it. It has multiple iterations through the same data set, a lot of complex mathematics. So this is how it goes. Typical machine learning problems are very similar to data mining. Classification, regression, ranking, clustering. Okay, dimensionality reduction is not a typical data mining problem. Because what is the problem of data mining? Data mining is not also the same thing as statistics. It must have one important property. It must be, the results must be understandable. Because we want to have actionable results, so they must be understandable. Now, if you know principal component analysis from statistics, you are trying to replace, let's say, set of 10 variables with subset of 3 variables, 3 artificial variables, which are called principal components, and you create them in such a way that you preserve the maximal possible variability. So let's say with first 3 variables, you can explain 99% of overall variability. So you reduce the number of variables you use in analysis from 10 to 3 without losing a lot of variability. The only problem is how do you interpret these 3 variables, also known as factors sometimes. So this is also known as factor analysis, principal component analysis. So what are these representing? You know, it's a bit of age, a bit of gender, a bit of occupation. It's really hard to interpret, so principal component analysis and dimensionality reduction is not a typical data mining task. Might be task for machine learning to reduce the complexity of the problem and to speed up the time. Less for direct data mining where people are using it. Of course, you can also abuse data mining algorithms for these things. You see, when I would use this kind of approach, when I don't care what this data means. Let's say fraud detection. You are searching for fraudulent transactions, anomaly detection, transactions that are different from other transactions. And I don't care what other transactions mean. I'm just searching for those who are different. So in this case, I can use dimensionality reduction. I can use this kind of approach where I don't even try to interpret the results. I'm only interested in this fact that this transaction is different from others. That's it. What does it mean? I don't care. As I said, mostly machine learning is machine data mining, people-oriented, but they are very close. We call primary techniques supervised, unsupervised in machine learning, and directed and undirected in data mining. But in data mining, we also use synonyms which are supervised and unsupervised. So you see, it's nearly the same thing. And again, it's also very close to statistics. But again, different, important difference. Data mining and machine learning, this is not science. Statistics is science. What does it mean? Basic distinction is very funny, but serious. Getting no result is a result for statistics, but not for data mining or machine learning because your customer will not pay you. So you continue with analysis until you get something. That's it. That's the main distinction between science and business. Okay. And of course, I mentioned already the important distinction, it must be understandable. Right? It must be understandable. And of course, even with machine learning, help of people is very, very appreciated. You get much better results. People know business problem. You know, even these algorithms are very prone on different data sets. You feed them with different data, with different columns, and depends on this data, you get better or worse results. So a lot of time you want to create derived variables from the source data because derived variables have more influence. You know, like obesity index has more influence on health than just height and weight, right? So if you know the area, if you have subject matter experts, you can make much, much better analysis. But basically, machine learning and data mining are nowadays used nearly as synonyms. Also, remember, the size of data set matters. If you use decision trees for machine learning, you should use it on sample. It's the same algorithm. If you are calculating simple average, then this is not called data mining. So, statistics. Statistics are samples. We call statistical samples small and big. And in statistics, small means up to 30 cases and big 200 and more. That's it. In between, it's a gray area. Data mining is not dealing with small sets. So data mining is dealing with statistically big sets from 200 up to, let's say, 100,000. Beyond that, it's machine learning. Over the time, right? If you want to get distinction. So Azure ML is a cloud application. Very simple to use with some algorithms out of the box. And on the top of it, it supports R, and from a couple of days or weeks ago, also Python. So it's extensible. However, Microsoft is trying to get some order into this R, right? So not all packages are supported. First of all, it's a little bit behind. It's not the latest version of R that it's supported. I have 3.1.3. The one that is in Azure ML currently is 3.0 something, so it's like 3 versions behind. Then not all packages are supported. But still, like Core R, ggplot, and many of these packages are supported. So still you cannot get rid about these syntax problems, not having consistent syntax. So still you need to use a lot of documentation for R. So workflow, you upload data or import online from some Azure storage. And connect to this historical data, then you build and validate the model, and then you consume this model through a web service. So this is nice thing, it's production ready. So you create so-called experiments. This is where you define data set and train the models and evaluate them, and then you select the best model and you create a web service. And you are working with cloud-based machine learning studio. So let me go there and show you a couple of experiments. So this is the link, and of course now I depend on web connection. It says, okay, it's here. So let me sign in, and you can get free account for testing. Okay? But it's limited. I have my own account, which is not so limited, so I can do a little bit more testing. So I created a couple of experiments. So here is where you start with experiments. Actually, I started with dataset, and I actually imported my same dataset from the target mail view. Same dataset I used in R, I already imported here in Azure ML. Please note that you pay also for storage. So you should take care what kind of datasets you are importing there. Remember that this is used for data mining, so it has 18,000 cases, so it's not a big deal. It's not a big deal. And you can always add a new dataset, right? Upload from some local file, and different formats are supported, or you can read it from some Azure storage. And then you go and create new experiments, right? Blank experiment means you are creating workflow similar to workflow in SSIS, right? And I already created a couple of workflows. So let me show you this bike buyer classification, and not this one, training experiment I wanted to show. So I started to read data, and then you simply add this, let me delete this one, add these components. So for example, to get the idea what's inside data set, I added descriptive statistics. And you see these components have these connecting points, in and out connecting points. So I'm connecting output from my data set with input for descriptive statistics. And this is very simple to use. You see, it has no parameters. It will give me something similar as summary command in R. Just this is internal in Azure ML. Then I'm splitting. I'm using data preparation function, split, which is somewhere here, feature selection here, no. Data transformation, sample and split. So I'm splitting this to training and test set because I'm using predictive models. I'm going to train models on 70% of data, and then try to predict this all test set. And on test set I have, this is known data, so I have the outcome of bike buyer, so I can measure which algorithm gives me better results. And then I'm using built-in machine learning classification algorithms. So I have 2-class boosted decision tree and 2-class naive Bayes plot machine. How many of you have played with analysis services data mining? Not many. You know, there you have only one decision trees algorithm. Here we have this different multi-class decision forest, blah, blah, blah. Actually, this is for the sake of simplicity. In analysis services, you have also all of these algorithms hidden, and you control them through parameters. But you can get binary tree, fully blown tree, and so on. So, I'm defining the decision tree, some parameters, and then feeding this with data. So you see train model, task has 2 inputs. And score model, I'm adding test set and making predictions. And then evaluate is comparing scores of naive Bayes and decision tree, so I can decide which one is better. I can simply run this, and you know, we are not there yet where Microsoft would like to be. Here you will see in the running, you will see soon how many seconds does it run. Microsoft wish is that this would be always below 30 seconds. Hopefully it will be, because we don't have enough time for longer tasks. It is. This one was very fast. So you see, now I can go here and visualize the results. So I have these basic statistics. Typically, you do this before you go to experiment. I already know these statistics, so I proceeded with experiment immediately. These are just parameters, so I don't have, visualization is data set, 70% and 30%, random split. This is nothing much to visualize here. These are just these parameters of decision tree and naive Bayes. Train also doesn't have anything to visualize, right? But important visualization comes here. And this is not graphical visualization. This is something that is really missing in Azure ML. So this is scoring. You see, I have my bike buyer, and this is prediction. So prediction for this case is 1 with 63% probability. This prediction is 0, but probability is very low, but still it's correct. So you will find also somewhere some incorrect predictions. Now the same thing you can check for naive Bayes, and then you can evaluate the model. And this is done graphically. So scored data set is the left one, and compared data set is the right one. So scored is decision tree, and the red is naive Bayes. Higher curve means better predictions, less errors. Okay? So we have better predictions with decision trees. Now once you do this, right, once this is done, you can just prepare. Now I should have run this again. As soon as you visualize, you lose possibility to create a scoring experiment. Now it's just update and it's disabled. But I created from this scoring experiment. So with a single click, Azure ML dropped everything that is not needed for production and added connecting points, web services input and web services output. So I don't need, this was source. Now for using this, I need input from a web service. Project columns if needed, and then score the model. Not train, the model is trained. So now I'm just joining new data to my model. And once this is done, I'm not running it again, so I'm not showing how this was done through a single click, because as I said, it would take too much time. Then you can publish, and I already published it. So I have my web service. And once I have my web service, here is GUID, how API key, and here is help, how to use it API by request response or for batch predictions. And I can even test this. This is very nice. I can even test this in Excel. So download Excel workbook is Excel workbook with macros that already call this web service. And I can test how these predictions are working inside Excel like you would do in your application. So enable editing and enable macros. Let's wait a second. And let me go to the left. So here are my parameters. I don't need customer key, but let's say I have married person. Let's say female with 3 children, 1 at home, bachelor's degree, occupation, let's say clerical. This should be the same data as you used as training data set. She doesn't have a house, she's got 1 car, she commutes 0 to 1 miles, she is from, let's say, Pacific region, and I don't know if I need, the more data I have, the better predictions are. But you see, for this kind of person, my web service is predicted that she will buy a bike with 86% probability. Now you can play with this and try different values. So for example, let's say that this person owns 4 cars. How does this influence on my predictions? So the probability that this person will buy a bike went down substantially. It's still more than 50%, that's why it is still declared as bike buyer, but already only 67%. Very nice, but what is really missing here is graphical visualization, so you cannot understand the tree. Now, what can you do? Let me go back to experiments and let me show you this one. And this one was already processed, so I can immediately visualize it. So I'm using what? I'm simply using R script to visualize my results of clustering. So with R script, I managed to get, so now I created clustering, 6 clusters. Clustering is undirected, unsupervised method. I'm just trying to find groups. After that, I have to realize what this group means. So without visualization, I'm lost. I should inspect 18,000 rows with cluster membership predicted, and then realize from them, okay, these are older people, managers, and so on. Now with help of R, I created graphs from this scoring. So now I can see what is inside each cluster, and now I can understand the data. And I have another R script here. Let me visualize this one. This R script is not just R script for visualization. This is actually using different clustering. So in Azure ML, we have only so-called k-means clustering. And in R, I have also hierarchical clustering. So what I have actually here is more or less complex R scripts. I have inputs, I can have 2 dataset inputs, some script, I can even zip script file and put it as input, and I have 2 outputs, textual, dataset, table, and graphical. This is what you get from R element. And this is complete R script, you see, which is defining data frame, creating hierarchical clustering and plotting hierarchical clustering and defining 6 groups. So together with R, we can make this Azure ML extensible, right? It is simple to use. But we can also add model visualizations. So we can also get over these limitations of Azure ML. Worth mentioning, what is the current price? So the most important is this one, 18 cents per 1,000 predictions. This is very low unless you are really dealing with huge data sets. Now, then it could become expensive. Now, imagine that you are collecting data from all of these fire detectors in the channel tunnel. And you try to use some predictions whether this is critical piece of data or not. Then you might do, I don't know, 1,000,000 predictions per minute. So this could be high price. The problem is that this is cloud-based, so you cannot get the model locally and make predictions locally. Now what can you do in this case? You go back to SSIS data mining, create model there, and then it's your local model, and then you issue queries, DMX queries, send queries to this local model. And you fully control the environment. In all other cases, this is very reasonable price. You know, if you are doing targeting mailing campaign to target million customers, you will pay how much? $180. And you are targeting million customers. So it's reasonable. Except for these really high-end problems. For these high-end problems, you might still prefer local solution to cloud-based solution. And as I said, visualizations, you can overcome these obstacles with R. Okay, so.
Basically, the more complicated part is making the machine learn, but then making the prediction is like this is immediate because it's just a vector with weights, and you just send some values, then multiply it with vectors, and then they charge you for that.
Yes.
So basically, they're charging you for the less expensive part.
They're charging you for the less expensive, yes, from the working perspective, from a real project, you are dealing with data 70–80% of time. And you do this in advance in your local machine.
Yeah.
So how does this process go? You calculate basic statistics to get overview, maybe in R. You do all of the transformations in SQL Server because you have all of the syntax there. And once data set is prepared, then you go to RStudio. To Azure ML, to ML Studio. It has also some data transformations there, but they are very poor. You have to use the right tool for the right task.
Do they have support vector machines also?
Yes, I will talk tomorrow about support vector machines in R and in NAR. They are not in SSIS, and they are the same in Azure ML. So yeah, tomorrow I have two presentations on all of these algorithms in SSIS, Excel, and R. Yes, please?
What's R's performance compared to Python or MATLAB? Is it quite good?
Performance, basically, you see, it is good. R is memory-based. Azure ML is scalable, right? Just don't forget that there is not much you can do for these complex algorithms like clustering and decision trees. They scan data multiple times. This is very common question even for SSIS data mining. I got very frequently question, how do I improve data mining training? By sampling, that's it. No index can help. The best approach is table scan. And if you scan table 10,000 times for a single training and this table has billion rows, what can you expect? That's why you do sampling. Okay, so, oh, sorry.
Do you know of any companies using Azure ML in the real world? Is there any production?
Let me put it like this. This is still not fully in production, so it's still developed. I don't know for a company that would use this already. I just know for a company, I created a fraud detection system from some Italian bank, and we are now evaluating whether it makes sense to switch to Azure ML. But I don't know for a real project. I did a lot with SSIS, but not with this one yet. Okay, so thank you, and enjoy the rest of the conference and lunch, of course. So, hello everybody. Thank you for coming to the conference and to this session, first real session after the keynote. The camera is already recording, so now it's a good time if you want to say hi to your mother, to step in front of it and wave a bit. After that introduction, we'll start doing some more serious things. So the title of the session is Introducing R and Azure Machine Learning, Azure ML. I'm Dejan Sarka. I'm working in IT sector for nearly 30 years, and actually my first job was data mining. Basically, it was even not called data mining. I dealt a lot with statistics in university, institute, and faculty for sociology. I am dealing mostly with SQL Server now, still with business intelligence, and still with these advanced tasks like data mining and now machine learning. You probably noticed that I'm not a native speaker. I'm from Slovenia, so I just finished my 13th book. So if you don't understand me, send me an email. Seems like people understand me better when I'm writing. So if you have any problems with accent, please interrupt me, ask me. Of course, I will repeat the same thing with the same accent, but at least we can get somewhere. And if it's still not understandable, just please send me an email. So what I'm going to talk about is R and Azure Machine Learning. And you know that for foundations, GNU General Public License. And there is core team that is developing R, and homepage is at www.r-project.org. So you can download R from there. R engine and R interactive command prompt. So we have a lot of statistical functions already built in. We have a lot of graphic functionality. And we have hundreds, or not hundreds, thousands of packages that expand functionality that you get out of the box. And of course, there are some drawbacks. So it is kind of programming language, so you have to get used to it. And it's based on, as I said, university, academic world, especially statisticians contributed a lot to R. So one of the things that might be kind of very hard for you if you are not proficient with mathematical or statistical fundamentals is terminology. So R is not using any kind of business-oriented terminology. A lot of statistical terms, and even in help, help is organized more academically than business-oriented. So typically, when you start researching something, you immediately open help and Google and search for the terms. What does this term mean, and what does that term mean? Nowadays, this is very fashionable. Everybody wants to do some kind of data science, programming, statistics, data mining, machine learning, of course, big data. These are now buzzwords nowadays. So where does R fit in? Actually, in Microsoft Suite, we have business intelligence developing from SQL 7. SQL 7 in '98 brought first time analysis services. Data mining first try was included in SQL 2000. And then it became quite mature in 2005. Did a little bit development 2008, and then it was more or less there, unchanged till 2014, when Microsoft shifted a lot to the cloud. So one of the problems why Microsoft didn't become so big player in this field is that data mining is mostly developed in universities, and people mostly use tools that are around from 50s. So statistical packages like SAS and SPSS started to develop in 50s already. And since these are the packages that are widely spread, it's not so easy to come into this area and say, now I have this great product, everybody starts using this. However, Microsoft did make an important change. Suddenly, with SQL Server, data mining was affordable for masses. You know, packages like SAS and SPSS are extremely expensive if you don't have some kind of academic license. They're there, so it's not like you would be lacking something for a real life project. Microsoft decided to make a breakthrough by supporting R. In Azure ML, R is supported. So what is R? So R is statistical programming language, open source language or package based on S language that was developed in 70s and early 80s in Bell Labs. So it's not just the algorithms, also the complete package, also the complete product is free. And because it is free, it is extremely popular, again, in academic environment, in universities. So it has become the most popular product in last 10 years in universities and even managed to overwhelm and overcome SPSS and SAS. So suddenly by supporting R, Microsoft got access to hundreds of different algorithms or hundreds of versions of the same algorithm, which might be good, but also might be bad. Now, in the second part of this talk, I'm going to introduce Azure ML. Let me start now by introducing R, and then we'll talk about pros and cons for supporting this in a business-oriented product. Basically, you will see we have this gap between academic and business world, which might be problematic sometimes. So, R is available free of charge. It is distributed under terms of the free software. It can be extremely expensive for business. Now with data mining included in SQL Server Suite in analysis services, if you've got SQL Server, you're done with all of the licensing. Also, Microsoft went even step further and released data mining add-ins for Office, especially for Excel, which enabled data mining even for broader audience. Still, as I said, Microsoft was somehow lonely in this field, so the amount of algorithms is limited. Even Microsoft cannot afford enough developers to develop all possible algorithms that are around known in the scientific world. Oh, and by the way, as I said, statistics, data mining, it mostly comes from universities, from academic world, so it has some specific rules that are not so common in business. So in data mining, all algorithms are public. Basically, you can get information about any algorithm that was ever developed, all of the mathematics behind, and what you do, you create your own product. So this is how data mining works. And also, Microsoft developed some own algorithms, like sequence clustering, and published complete mathematics behind, so any other company can take it and include this algorithm in their own product. Anyway, since, as I said, the amount of algorithms that Microsoft supported was still kind of low compared to competitors' products, although all of the most important algorithms